look at vectors, a lot of times we don't like to have to draw vectors and add them head to tail and tail to the first, head to the last. What we can do is we can represent them as numbers. And the way we do it is that, let's say I have this vector A. Everybody look up here. Is this vector the same here as it is there? How about over here? Same over here? Yep. So where's the most convenient place to set this vector? What's the most convenient place? So the tail is on the origin, because if the tail is on the origin, x minus 0 is going to be this position, y minus 0 is going to be that position. So having the tail at the origin makes everything easier. So when we see what we call a column vector, this is the location of the head of the vector. XY. And then we assume then the tail is at the origin. Very big. Sometimes you'll have to move points so that you get a tail of a vector at the origin. We'll deal with that. But for right now, this is the notation we have. So this is called the column vector. It's my favorite. It's the quickest, the easiest to do. The second one uses this idea of little vectors. We'll call them unit vectors. This unit vector is left or right 1, and then up or down 0. So here's left or right, right 1, down 0, right 1, down 0. How many of these does it take to get horizontally to xy? How many does that take? 5. 5 of these little I unit vectors. Then to go up, we're going to go 1, 2, 3 of these little ones. 3 of the j unit vectors. And so 5i plus 3j is the position vector form for column vector 5, 3. This vector A is this 5, 3 when the tail is where? At origin, yep. Just keep that in mind. Well, let's see how, kind of a sort of a proof of this. We're going to call this vector A the head of xy. Well, that's the same as x0 plus 0y, because x plus 0 is x, 0 plus y is y. Now, we can write this as a scalar, x times 1, 0, because x times 1 is x, and x times 0 is 0. Same with y. Y times 0, y times 1 is the same as 0y. So these are what we call the unit vectors. This one's I, and this one's j. So you have x times I plus y times j. This is my position vector form. Is it reasonable that you could go to 3D? Make this three-dimensional? So instead of just having xy, we can have xyz. Then the position vector is xi plus yj. What do you think the next one's going to be? Z what? K, yeah. And that just is coming out of the board like that. All right. So what's the point of all this? Well, the point is to make your life wonderful. So adding and subtracting is easy now. As long as the tails are at the origin, everything gets easier. So here's vector A, here's vector B with their tails at the origin. We can find this location, 1, 2, 3, 4, 1, 2, 3, so it's 4, 3. We can find this location is back 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5. So back 5, up 5. So adding vectors couldn't be better, because now we're just going to say A plus B is going to be A, 4, 3, plus B, negative 5, 5. And do you like adding in horizontal lines, horizontal rows? You'll love this. 4 minus 5 is negative 1. 3 plus 5 is 8. This right here is the sum of A plus B. Let's see if it actually works. So here is A, vector A. Here is vector B. Adding them head to tail, the resultant is from the tail of the first to the head of the last. So from the beginning, I'm going to go back 1, up 1, 2, 3, 4, 5, 6, 7, 8. It works, doesn't it? Perfect. Let's try A minus B. A minus B is just going to be 4, 3 minus negative 5, 5. So that's just going to be 4 plus 5, 3 minus 5. So this one looks very different from negative 1, 8. This is going to be 9, negative 2. Well, let's see if this actually works. If I remember right, I think I had A as this one. Okay, I'm going to put A about here. And then minus B is going to look like this. I'm just going to squiggle this little arrow out here, make the arrow here. So when we drop from the tail of the first to the head of the last, we had A here, 0 to there, minus B here, down to there. I'm going down, I'm going over 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going down 1, 2. It works. So you don't ever have to draw vectors again as long as the tail of the vector is where? Origin, and then you're good to go. Now we can do this one, 2A, which was 4, 3, minus 1 half, 1 half B, which is negative 5, 5. Okay, so 2 times 4 is 8, plus 5 halves, and then this is 6 minus 5 halves. And I have to do a little bit of common denominator. 16 halves plus 5 is 21 halves, or 10.5. And this would be 12 halves minus 5 is 7 halves, or 3.5. And there you go. You didn't have to draw a thing, and that's where the head of that vector would be if you move the tail to the origin. That's it. So for homework, we're going to go to day 3. And the first ones, you're just going to say, oh, okay, A here is, put it in a column vector form, 1, 7, negative 1. And then you can figure out what B is going to be, right? B is going to be what? Just shout it out. B is 4i plus 7j, so we just put 4, 7, and 5. There you go. Okay. And then you just do what it says, 3b, 2a minus b. Do the same with these. And then next one, 3 should be fine. Put a double circle around number 4. This is the most important concept of this chapter, this problem right here. It's easy to do, but you have to understand number 4. And then 5 will be interesting. 6 is kind of the same as before. 8 is where we are going to be solving. So what they have here is they have A times the vector 7, 7, 4 minus 3 times the vector 3, negative 1, B should be equal to negative 37, negative 25, and 5. And then you're going to solve for, you'll make some equations here and solve for A and B. You'll do the same thing with this one, setting it up and finding X and Y. And then there's a nice application with submarines that you can do for 10. Read and then interpret. That is vectors with numbers.